Yes. First of all, good evening, all of you, and sorry for delay. You have to wait for about 15 minutes. Everything is fine, and I hope that you are also doing well. Today, we are going to discuss about the finite difference method for higher order, and there was some queries yesterday, and I provided the solution for the same. Okay, and how you we can use this finite difference method for higher order. Okay, it's quite simple. First, I need to share my screen with you. Then we discuss all these one by one. I hope my screen is visible to all of you. My screen is okay.
Yes, sir.
My screen is visible, and now this is also okay. Yes. Okay. So I need all these. Yes. So when we are thinking to apply finite difference method for higher order, and as you know, yesterday we discussed about the finite difference method, and mostly we will use central difference. Okay, and for the same, first order, second order, third order, and fourth order. See here, this will be required when we will apply this finite difference. So y dash I will be equal to, note this, will be helpful to implement this finite difference. This will be equal to yi plus 1 minus yi. Okay, and for the second order, we will have yi double dash is equal to 1 upon h square. Okay, and yi plus 1 minus 2 yi and plus yi minus 1. And for the same third order, we have yi triple dash will be equal to 1 upon 2h cube. Yi plus 2 minus 2yi plus 1, and plus we have 2yi minus 1. Then we have minus yi minus 2. This is for the third order, and if we need for fourth order, then this will be equal to 1 upon h square, and here will be yi plus 2 minus 4yi plus 1, and plus 6yi, then minus 4yi minus 1, and plus yi minus 2. So these are the equations which we need to first equation, second, third, and fourth, which are highly useful when we will apply. We want to find out the solution of any different ODE of higher order, whether it is second, third, and fourth. So these equations are up to fourth order. If you need more order, then you can easily establish by using Taylor series, the book which I shared with you. And yesterday in the beginning, I already shown these few formulas, okay, and which are available in the same book. Okay, so these are required for ODE, second order, third order, and fourth order. So there are two approaches to find out the solution of ODE, higher order. We can use matrix as well as iterative. Okay, both are very useful. But in this session, I include only iterative approach. For the matrix, we need to use some different approaches which are available in the matrix to find out the solution of a system of equations. Okay, so here we will start by using iterative approach. Okay, so corresponding to this, we will use, and then we will find out the solution of the given boundary value problem. And see, here is the MATLAB window. So here is the MATLAB window. And we have in this, there are four examples I choose to find out the solution. See, in the very first example, we have here uh, y double dash plus 2y dash plus y is equal to 0, and these are the conditions: y0 is equal to 1 and y dash 0 is equal to 0, and we want to solve for the interval 0 to 5. Okay, so the most important thing is to establish, you can see this equation, okay, with the help of a finite difference method. And how you can do this is very quite simple. So first, what we do, we need to y double dash, okay, and y double dash will be equal to equal to, as you know, yi plus 1 minus 2yi, and plus we have I minus 1 upon we have x square, and then we have at this place y dash, and y dash will be equal to yi plus 1 and minus yi minus 1 upon 2h. Okay, so corresponding to this order of derivative, we required these differences. Okay, and also the conditions which we are given when we will put these values in this equation. Okay, so this equation will be in this form: yi plus 1 minus 2yi plus yi minus 1 upon h square. Okay, then we have plus 2y dash, and value of y dash we have is this one. We will put at the place the yi plus 1 minus yi minus 1 upon h, 2h. Then y, this will become yi plus yi, and is equal to 0. After simplifying this equation in terms of we want for this value. Okay, so we will solve this equation for yi plus 1, and after simplifying, you will have this equation: yi plus 1 will be equal to 2 minus h square yi minus 1. Okay, then minus we have 4 minus 2h square into yi. Okay, and upon we have 2 plus h square. So when you will simplify this expression and you will solve for yi plus 1, this equation is required to convert the given boundary value from in iterative format, and only this expression will be required, and following the same we can easily write the equation in MATLAB and using the loop. Okay, so along with what we have, as you know, we are given these two values. Okay, so here how you will use y0 is equal to 1. So this will be y naught is equal to 1. And what about y dash? This will be equal to y naught plus h y naught 0. Okay, see once again. Yes. So what about the second condition? Y dash 0 is equal to 1. We can write this in this way. Y1 is equal to, we have y naught plus h and y dash 0. Okay, but the value of y dash 0 is the value of y dash 0 is 0, and when you will put at this place y dash 0 is 0, so this will be y1 is equal to 1. So you will have y naught is equal to 1 and y1 is also equal to 1, and now we can have all the conditions which we can convert into the syntax of MATLAB. So what we will do, you can see here, this is the length of the domain. L we have is 5. Okay, since we are given 0 to 5. Okay, and h will be equal to, we can find the length of each grid that will be given by L upon n minus 1, or either you can use b minus a upon n. Okay, same thing. There is no difference. After that, we need X line space, and you can have 0 to L and N. Then Y zeros will be equal to Y will be equal to zeros 1 to N. These are the same. Now we want to apply the boundary conditions. Okay, so this is the first boundary condition. The meaning of this one is Y naught is equal to 1. Okay, and corresponding to the second boundary condition, which is Y dash 0. Okay, and Y dash 0, after using the same this condition, you can see that the value of Y1 is equal to 1, and 1 is again equal to Y naught. Okay, so when you will use index, so Y1 means the meaning of this one is Y naught, and the meaning of this one is Y1. Okay, and Y1 is equal to Y naught. So these conditions are applied at this place. So we have the index I is equal to 1, I is equal to 2, and now we will use for loop to compute the other values of Y. Okay, we need to compute only the internal points. Okay, if we have uh, this is the interval x naught and here is xn, we need to compute the values corresponding to these points only. Okay, so this is the initial point and this is the last point. So the loop will we will apply I equal to 2 to n minus 1. Okay, and this is the for loop, and when you will put all these values at this place, you can have all the values of y corresponding to x input, and this will store all the values in y vector and in x vector. And now I can delete all these, and then yes, now you can see the other part are quite simple. Other part are very quite simple. Just we are using here plot function, x label, y label, title, and grid on. Okay, only the new thing for this method is only this part. Okay, so the initial conditions or the boundary conditions, then plot the graph. So these parts are always remain same in every method. Okay, but only this part will change. Only this part will change. And when you will execute, when we will execute, and you can see we have, yeah, we have this solution corresponding to this problem. Any question, please? Any question? Please let me know if there is any doubt, any question. Is it okay?
Yes, sir. Yes, sir. Everything is okay.
Okay. Once again, I am sharing my screen. Yes. So here is also we have one more example, but the example is that y double dash x plus yx is equal to 0. Okay, we have only this with the boundary condition we are given here is y0 is equal to 0 and y dash 0 is equal to 1. Okay. So this is also the same approach, no big difference. Just you need to put the value of y double dash x, okay, which will be equal to this one, and yx will be yi. So this is the equation, and you will rewrite this expression for yi plus 1. Okay, for yi plus 1 we have this equation for the above given problem. And now the other parts, these conditions are the same as we discussed in the first example. Okay, and you can see we have endpoint, L, H, line space. These are the initial conditions which we are given. Okay, and then after this is the final difference, and you can see this equation is the same as we established at this place. Just we convert this equation in this form in MATLAB syntax. Okay, and the other parts are same. And when you will execute this section, you can find. Yes, okay. So this is the solution of this differential equation, second order differential equation. Okay, and you can easily apply. And ODE, this is the one more example is there. Okay, and in this example, what is there? We are given this differential equation. Just 1 minute. So here is this is the given differential equation. Okay, we are given dx upon d2x upon dt square is equal to minus k upon mx. Okay, where m is the mass and k is spring constant, x is the displacement. Okay, but we can write this equation in this form. If we have dx upon dt is equal to v, then dv upon dt will be equal to minus k upon m into x. So now we have these two equations. Okay, and again, when you will use uh, backward finite difference. Okay, so this equation can be used as vi minus vi minus 1 upon dt will be equal to minus k upon m x I minus 1. And for the same, you can use this equation can be written as xi minus xi minus 1 upon this is dt and is equal to vi. Okay, so you will have these two equations, and we can in this method what I have done, we plot the graph for both the equations. We have now these two equations. Okay, and the interval which we choose at this place, you can see the parametric values for m is 1, k is equal to also 1. Okay, and the interval is 0 to 10. This is the initial value and of the interval, and this is the last value of the interval, and the value of h we are choosing here is 0.01. Okay, so this is the dt or delta t, and you know delta t is equal to h. Okay, and this is the t vector. This is the t vector, t start, t end, and this is the step size. Okay, then after we have, okay, yes, then after we have these are the initial conditions. X naught is equal to 1 because we need to apply the initial conditions whatever we are given. Okay, but here we are choosing x naught is 1 and v naught is 0. Okay, and you will initialize both the vector for x as well as v. Okay, x is for the displacement and v for the velocity. So both must be have equal length, and then set the initial conditions x1 and y1 will be x naught and v naught, okay, which are at this place. Okay, and now we are using finite difference method to solve this ODE, and you can see that vi will be equal to, this is from the first equation. Okay, you can see this is vi and this is xi, and then after we have the plot for these both equations. Okay, and for vi and for x both must have the same length because we are passing the value of t vector for v and x. Okay, so all the assignments will must justify these two both equations for x and v. Okay, so this is the code for first graph t and x. Okay, for the displacement, and the second code is for velocity. Either if you want to combine, we can do, but here when you will use a figure at this place, and then or either you can use figure 1 in this way. You can use figure 1 and this is figure 2. You can use in this way also. Okay, and when you will execute these sequence of statement, okay, and see, yes, you can see there we have two graphs. So the first graph is displacement versus time, Okay, on the horizontal line we have the time, and on the vertical we have displacement. And in the second one, we have on the horizontal line time, and on the vertical we have velocity. So here is velocity versus time. Okay, so the approach which we employ in this example is finite difference. If you want to find out a direct solution for only the second order differential equation, which is in the figure 2, okay, you can directly use the central difference and put the value as we do in the second example. Okay, you will have the same graph. There will be no difference. So this is all about for the second order, or you can use this finite difference approach for higher order also. Okay. There is also one more example I introduce here. Please let me know if there is any question related to this second example and the third example. Yes, please. I tried as simple as possible from my side, and I hope that it is clear. Yes, please. Any doubt? Sahid, allow your problem has been sorted out now. I think you sent me the problem yesterday.
Yes, I'm having network issue. I'm just joining again now.
Okay. So
I'm
a problem which you send me, and that was associated with the second order. Okay. And now you can use this approach to solve the same problem. And I hope you will try. Okay. Any more question, please? Any more question? You can use this approach for third order and fourth order. Okay. In the beginning, I give the finite difference for up to fourth order. Okay. If you have higher than the fourth order, you can find by using the Taylor series, which is available in the book which I sent to you. You can take help from that place. Okay, but this is the approach to use finite difference to find out the solutions of second order, third order, fourth order. Okay, and also there is one more example, but I, yes, here is the example. Okay, you can easily understand this example if you can solve the system of equations using matrix. Okay, so the same approach is used at this place. Yeah, Gaussian elimination method is used at this place. So what you will do? First, you need to convert this equation. Okay, just please give me 1 minute. How you can do? Yes. So before applying this Gaussian approach, and how you can compare the coefficients. Okay, this is very important. I have one example, and the example one is, yes, okay. I have the example we have is y double dash. Just 1 minute. Okay. The example is y double dash is equal to x plus y. And y0 is equal to y1 is equal to 0. Okay. So to find out the solution by using the finite difference. Okay. See, if you will draw the graph, here is x0. Here is x is equal to 0, and here is x equal to 1. Okay, so x naught, this is the x naught is equal to 0, and we will divide, this is x1, x2, x3, and x4 is equal to 1. Okay, so the value at this point is 0, y naught is equal to 0, and also y1 is equal to 0. Okay, so what about the intermediate point? So we need to compute these values. This is y1, y2, and y3, h. Okay, so when you will divide this interval, we have x1. H will be equal to 1, 2, 3, 4. Okay, so h will be equal to 1 by 4. x1 will be equal to x1 will be equal to 1 by 4, and x2 will be equal to 1 by 2, x3 will be equal to 3 by 4, and x4 will be equal to 1. Okay, so these are the intermediate points, x1, x2, and x3. Okay, so what we do now, the value of y double dash will be equal to 1 upon h square, then yi plus 1 minus 2yi plus yi minus 1. Okay, so when you will use this value in the given differential equation, this will be reduced to 1 upon h square yi plus 1 minus 2yi and plus we have yi minus 1. Here is minus 1. And then on the right hand side, x plus y, this will be xi plus yi. So when you will put the value of h at this place, okay, and this will be reduced into in this form. 16, the value of h is 1 by 4. Okay, so this will be yi plus 1 minus 2yi plus yi minus 1 and xi plus yi. Okay, so you will rewrite this expression and can be written as 16 yi minus 1 minus 33 yi, then plus we have 16 yi plus 1 is equal to xi. Okay, now what you will do, you will put I is equal to 1. For I equal to 1, this equation will be 16 y naught minus 33 y1 plus 16 y2 is equal to x1. Okay, and when you have I is equal to 2, then from this equation we will have 16 y1 minus 33 y2 and 16 y3 is equal to x2 when we have I is equal to 3. So again from the same equation, from this place we have 16 y2 minus 33 y3 and plus 16 y4, okay, is equal to x3. But the value of y4 and y naught are 0. These values we are given. Y1 is equal to, this is y4. This is y4, okay. Corresponding to x4, we have y4. So value of y4 and y0, both are 0. So this value is 0 and this value is 0. So we have three equations, and from these three equations, these are the system of equations in y1, y2, and y3. Okay, we have the values of x1, x2, and x3. These are the values of x1, x2, and x3. We will put on the right hand side, and after the simplifying, these equations can be easily converted into matrix form. Okay, we will have take the coefficients 16, 0, 16, minus 33, 16, and 0, 16, and minus 33. And here we have y1, y2, and y3, and is equal to, we have, this is x1, then we have x2, and this is x3. Okay, so now you can use any method to compute value of y1, y2, y3. Okay, so the thing is we can now use there are several numerical approach to find out the solution of the system of equations. Okay, so in this way we will convert we can easily convert the system of equations in matrix form by using the finite difference approach, and then we can write the program for the same. Okay, now this explanation will help you. So these are the coefficient. Okay, this is, see, this is A11, A22, A33. So you can see here A, I are equal, and these are, okay, and see, these are the diagonal element. Okay, tri-diagonal approach also we can use. Okay, then you will take this element, this element, this element, this element. Okay, so MATLAB, we are using in this way. Okay, if I, j and I is less than j, okay, so when I is less than j, then we have this element and this element. When I is greater than j, when I is greater than j, then we have this element and this element. Okay, so there are two ways. One is I is less than j, or I is greater than j. This is 1 2 I j. I is less than j. Okay, so for I is less than j, we have this element, and for I greater than j, we have below the diagonal element. Okay, so this approach will help you to understand the code which I'm going to show you now. Yes, now I have to close, come to MATLAB. Yes. So we have the example. But the thing is that you have to convert all these equations. Sorry, equation is missing. Equation is missing in this. Okay, just 1 minute, please. Example is missing. Okay, you can see here. Yes, we have this example y double dash plus 2y double dash. Sorry, this is not 2 double dash. This is only y dash. Okay, you can see this example. Okay, and this is a second order differential equation, and here we have is y0 and y1. Okay, so now the first thing is you have to convert these equations in iterative format. Then you need to compare the coefficient after converting in matrix system of equations. Then you can compare the coefficient. Okay, these are the diagonal element. You can see this is the diagonal element which are available in the matrix when you will convert this equation in the matrix format. Okay, so all the diagonal element will be same. You can see in the explanation, all the diagonal elements were equal. Okay, so here will also be AII. AII means all the diagonal element of the matrix will be equal. Okay, and then these are the if I is greater than 1, if I is greater than 1, then I minus 1 will be equal to minus 1. These are the subdiagonal. All the elements below the main diagonal element, we have minus 1. And also again, if we have I is less than n, okay, I is less than n, these will be the coefficient or the elements of the matrix which are above the diagonal. Okay, so these are the super diagonal elements. So all the elements which are in the matrix can be expressed in this way. Okay, and one more thing, the matrix will be tridiagonal. Okay, what do you mean by tridiagonal matrix? Only there will be one main diagonal, and then one will be sub, and one will be above, super. Okay, other elements will be zero. Other elements will be zero, like in this way. Say, like in this way. When you will compute, this will be this element will be 2 1 plus h, 2 1 plus h, and so on, 2 1 plus h. Then we will have here is minus 1 minus 1. Okay, and here will also be minus 1 minus 1, and so on. So other elements will be 0 in this way. The other elements will be 0. This is also 0. Here will be minus 1. This is also 0. Okay, and if you have 2 1 plus h, here will be minus 1, and here is also minus 1. Okay, so only this is the main diagonal. These elements will be minus 1, and these are also minus 1. Okay, so all these are expressed. Subdiagonal means this element will be minus 1, and superdiagonal, these elements will also be minus 1. When you will compute, the matrix will be in this form. Okay, so is after that. This is the right hand side. This is the right hand side part. So one will be the b1, and b will be equal to h square x to n minus 1 h square and minus 2h square. Okay. And B1, this is the at x equal to 0, and this is the end point. So the top value when we have x, no, x is equal to 0 and x equal to 1. So this is the corresponding to the initial values and the last value, and these are the intermediate. Okay, so all the values for the B matrix we will compute here. Okay, then after we are using to solve the tridiagonal system, and y is equal to a backslash b. This will return the solution of the above system of equations using matrix. Okay, so I will recommend you also, you must go through the how you can find out the solutions of a system of equations using matrix. This will help you to understand, because in the beginning we did not introduce about this one. If you want to go through, you can go to here. You can take help from the MATLAB. Okay, matrix. You will go to matrix square and n by n, matrix augment, exponential. Okay, so just 1 minute. First, see this one. So this is the entire code, and after that you can plot the graph. Okay, and when you will run, you will have the graph of the second order differential equation. Okay, sometimes we can use or we can take the help. We can use the matrix to find out the solutions of a system of equations. Ultimately, when we will apply this finite difference, sometimes we can use matrix approach, and you can use the other approach also. Depends upon our choice. So if sometimes you need to apply this matrix system of equations, when you will have, you can use this matrix approach also to find out the solutions of given boundary value problem. So one question is there, how you can find the solutions of a system of matrix. Solution of system of matrix, system of equation. I'm not sure whether it will be returned. Okay, not returning. Okay. Okay, but the thing is that only this is the way to find out the solution of the system of equations. When you will convert all the equations in the matrix form, y is equal to a backslash b. This will give us the solutions of the matrix system of equations using matrix. Okay, so this is the right hand side, and this is the matrix A. Okay, so all the elements of matrix are stored in A. Then we are using tridiagonal system of equations, and this will give us the solution of system of equations. And also the same approach we can use for this example. Here is the example, this one, but here I did not introduce the equation. So when I will upload these file, I will insert here the equation of the differential equation. Okay, so here is also the same approach, but we are using here Gaussian elimination. Okay, but the approach is same. Y is equal to a backslash b. B is the these are also the boundary conditions. Okay, and you will have the solution by using matrix. You can see here. Okay, but the thing is, you need to convert the given problem into the matrix format. You will have the system of equations. Then from that place, you will find out all the coefficients. You will establish the matrix. Then you will implement MATLAB code. Okay, so you will try this part yourself. When I will upload the file, the code, the differential equation, I will put at this place. Okay, so this is all about the finite difference method for the higher order. There are two approaches, and both we discuss in the detail. I hope this will help you. Any question, please now? Any question from your side?
Hello, sir. Can we generate numerical values instead of having graphs?
Pardon?
Can we generate numerical values instead of graphs?
I don't get your question.
I said, can we generate numerical values instead of graphs?
Okay, numerical values. Yeah, we can generate the numerical values also. We can generate numerical values. We can generate the numerical values. Okay. See, okay, this is the This is the first example, okay? And when you will execute this file, and now come here in the workspace. See, this is the T vector and this is V. CLC. Use here CLC and clear. Okay. When I will execute this file, see on the right hand side. This is X and this is Y. This is X and this is Y. If you want to extract in the command window, what you will do, we have X transpose and Y transpose. These are the numerical values. These are the numerical values. And also you can extract from this place. Answer. Yes, these are the numerical values. You can see. You can see here the numerical values from 0 to 5. 0 to 5. And these are the corresponding values of Y. See, the length is 5. Okay, interval we have is 0 to 5. And we break this interval in the sub intervals or the points by taking this step size. Okay, and corresponding to this, we have the numerical values in the workspace. When you will click and open, these are the numerical values. Got it? Is it okay? So when you will select this one and now come to plot, we have the same graph. Okay, you can take in this form also. And there are so many options to plot the same graph. You can use semi-logi. Okay, this is the plot, and you can use stairs also. You can use stem, so you can use all the formats what are available here. Okay, but usually we are using this function. If you will convert in the scatter, this is a scatter plot. Okay, so yes, got it. Any more question, please? This is all about today's session, and I hope that the finite difference method is very clear. If still you have any question, Sima Mandal, to everyone, Sima Mandal saying something. Chat, okay. मेरे डाउट का कुछ बता दीजिए जो सेंड किया था टू टाइप्स प्लॉटिंग टू टाइप्स प्लॉटिंग yes you send me one prompt two types of plotting we can do but now, sorry, I forget about the exact question. I came to know there are some parameters, I think. Sima Mandal, I think there is some parameters in your equations. WhatsApp पे send किया था. Okay, okay. Yes, yes, yes. I know, but I think I did not try. We can do, but sorry, I did not try. And after doing the same, I will share with you. Okay. Yes, please remind me, or you can drop the message after 9 p.m. today so that I can spend some time. Don't worry. And also, there was one more question, one more prompt from the participant saying how we can plot. That also I try to introduce here, and the solution for the same I sent to, okay, I sent to, I think the prompt was related to Imtiaz. Yes, so yeah, here are the solutions. Okay, so in the case his question was that for the different range of n values, how we can plot. Okay, so first see the graph for this one, and then we will discuss. So this was the question. He's saying that if we have n equal to 10, n equal to 20, n equal to 30, n equal to 40. Okay, so how we can plot the graph? Known as multiple graph on the single plot. So how we can generate this one? Very quite simple. Just we have the values of n. We have to define the range of n values. Okay, we have 10, 20, 30, and 40. What do you mean by this? These are the number of points. Okay, n equal to 10, 30, 40, and 50. Okay, so here then we choose the loop for each values, for 10, for 20, for 30, and for 40. So for this we have to apply the loop. Then here is the loop, idx is equal to 1 to length n values. So this will pass 10, then pass 20, 30, and 40 from this n value vector. Okay, and this is the line space, and all this value will be stored at this place. So when this will be n equal to 10, this will generate corresponding to 10 points. Then we have 20, this will pass, okay, and generate 20 points, then 30 and 40. And here is we have a y function, and then we have the float, and then you can insert legend. Okay, legend will also will be based on this IDX, which we create at a space. Okay, correspond to this one. Okay, and then we have we have multiple graph, so we have to use hold on, and then we have the X label, Y label, hold off. And when you will execute, you will have this graph. Very quite simple. And also I tried to put one more example for the same. Here is 1, 2, 3, 4, 5. Okay, the approach is the same. And when you will execute, see, for n equal to 1, n equal to 2, n equal to 3, n equal to 4, and n equal to 5, we have multiple graphs by using the single code. Okay, so here we have the x, and here we have is y. Okay, this is the line space. So for the different values of n, we have we can pass at a space, but the line space for each will be same. X is equal to, we have 0 to 2 pi for this function, but you know when we have sign x, 2x, 3x, 4x, and 5x, we have different functions. Okay, but we want to plot all together. Then you can generate this vector and apply the for loop. And just only the one thing, how you can use for loop. For loop play very important role in various type of problems. And along with the, I many times told you that computing thinking, how you are using all these control statements, logical statements, okay, and the syntax to convert in the MATLAB. So behind all these concept, clarity in the concept are very important. Then after computing thinking, logical thinking, write the program yourself, and accept the challenges, and try different type of problems, and one day you will be expert in your domain. So this is all about today's session, and I hope that all of you enjoy. And thank you very much to listen me very carefully. And now the content for today, yesterday, and there are some lectures are required to upload on YouTube. Okay, because of my assistant